We're going to talk about sustainability today. There was a couple readings that were posted on Moodle, which I hope you got a chance to look at, and I'm going to try to tie that in with some of the textbook material to try to make sense of this topic. So it's a difficult concept to define. Um, there are basically two basic philosophies on sustainability. The first is known as the strong sustainability perspective. Um, that idea holds that natural capital, or the amount of land and natural resources that are on the planet, those include, just the atmosphere, the water, the soil, the materials, the minerals, the forests, as well as just kind of the cycles of minerals that, the phosphorus cycle, the nitrogen cycle, the carbon cycle, the water cycle, the ways that those minerals and materials get cycled through um, the natural biological systems. That's kind of what's called natural capital, which is um, one of the factors that allows life to be sustained on Earth. And so the strong sustainability perspective holds that this natural capital is kind of in a category of its own, and it's not really able to be substituted with human-made capital like machines and computers and knowledge. Those things aren't able to be swapped in and out for one another. Natural capital is special in the way that it allows life to be sustained, and so that is sort of off limits and must be maintained basically at any cost in order to sustain life on Earth. That's kind of the perspective of strong sustainability. The other perspective of weak sustainability holds that it's okay to deplete or degrade natural capital. It's okay to deplete and degrade those stocks of natural resources, those materials, those wildlife, the soil, the water. It's okay to deplete and degrade those, as long as whatever you're doing with that activity, however that process of production which degrades those resources, however that works, as long as that's producing some kind of capital of some other type that is going to increase production capacity in the future, then that's a justified use of those resources. If you're using those natural resources to produce and increase your capacity to produce more things in the future, then you are essentially making yourself at least as well off in the future as you could be otherwise. And the key assumption that is being held by this weak sustainability perspective is that those natural capital resources and the human-made capital, those are able to be substituted for one another, that those can be swapped in and out. You can replace natural capital with something man-made and be just fine. That's the underlying assumption of weak sustainability. Okay. So those are two terms that I wanted to define in advance, because they sort of characterize the different perspectives between ecological economics and environmental economics. So one of the perspectives that we did get to see in the readings was sort of the economist perspective, which was represented by Bob Solow, Nobel laureate economist, who wrote, or he gave a lecture on this topic, which was eventually rendered into an article. So he had some thoughts on sustainability, and I'm wondering, what were your takeaways from this article? Is there anybody that has maybe a key point that they took away from Bob Solow's perspective on sustainability? Does anyone want to volunteer to explain what you got from this article?
I thought that he said that sustainability was our moral obligation for future generations, to uphold them something to have in the future.
Yeah, for sure. Yeah. So he said he made the point that there is a moral. The key idea that sustainability has to be about is some kind of moral imperative. And so that's definitely an important point that he made. Yeah. Anyone else have anything you took away? Yeah, Cassie.
Also, I saw that he was talking about how certain resources can take other resources' place. So you can use up one resource if it can be substituted with another resource that's still available.
Yes, exactly. Yep. So substitutability. Any other impressions or takeaways from Bob's solo?
He talked about one of like the challenges of sustainability is that like we don't know the preferences of the future generations.
Yes. Yeah, that's exactly right. We don't preferences as well as the capacities of the future. Those are unknown. Yeah, exactly. Jack, do you have your hand up?
Yeah, adding to that, kind of just like the difference between saving and investing, and then sort of like the decision between consuming or saving in the future. I see those as kind of parallel.
Yeah. Yeah. So yeah, I think one of his core arguments is that sustainability is about, yeah, consumption today versus investment. Investment being kind of a delayed gratification, which will allow you to consume more in the future, which in the long run is sort of letting your future generations, your children and your children's children, consume in the future. Yeah, so it's, yeah, investment is kind of the key point. Yeah, there's one point in the article where he talks about if you're if you're preserving the environment but you're not but you're sort of putting those resources for consumption and you're not investing anything, then that's, you could argue that that's not necessarily sustainable because you're not increasing your capacity for future production, even though there's maybe some preservation of some environmental resource that you're undertaking. So yeah, investment is a key. Yeah, these are a lot of the key points. Anything else? Anyone have anything further that we haven't mentioned already?
I guess just going off like the investment thing, he talked about like poor people now and that like we do nothing to help them and like how we could help them by increasing like our current consumption and stuff, but that would take away like the possibilities of the future.
Exactly. Yeah, that's the paradox of sustainability, which is which is actually really tricky. Like it's yeah, that's a very tricky issue because the logic of sustainability says that we want to defer to these other people. We want to sort of prefer them and give them an ability to be better off. Some of them don't exist yet. And so that if you take that ethic to its logical conclusion that you think people are being shortchanged and you want to somehow rectify that, the logical question then is there anybody being shortchanged right now that we ought to be looking out for, rather than looking out for future people? And that's yeah, that's a very tricky problem. It's almost like the logic of sustainability almost undermines itself in a way by pointing out that if you're so concerned about these other people in the future, you ought to therefore be perhaps concerned about people today that are not consuming, and that consumption, having more prosperity or having a better quality of life is going to come from consumption, not investment. If you're investing, you're deferring consumption for later. But what some of these people need right now is the ability to consume right now because they're very poor. Yeah, so I think we've hit most of what I wanted to highlight from this article here. So these are some of the things that we just as a class have sort of summarized. I have just a couple points that I wanted to highlight. One of these is that one of his main points is that it's basically impossible to leave the world exactly as we found it, and it might not even be desirable to do that. If our ancestors had left the world exactly how they found it, we would be much poorer than we are right now, and so it's not obvious exactly what you mean by preserving the world or maintaining the world, because changes, the changes that we make to our environment, to our life, a lot of times those produce a lot of good things. And it's also, anything you do on the planet is going to leave some kind of impact, and to think that you can't make any changes at all is almost impossible to do. That's kind of the first one. And then what he sort of goes into after that is he says, rather than thinking about it in terms of giving the same world, exactly the same world to the future, it might make more sense to think about what can we do to make the future at least as well off as we are in whatever way that they want to be. Because going back to one of the points from before, we don't exactly know what their lives are gonna look like, or what their preferences are gonna be, or what capacities they're gonna have. And so giving them as much of an option, giving them as much capacity as possible might be the best that we can do as it relates to that, because we don't know them. They're not people that we can ask about what their preferences are. So making them at least as well off as we are is sort of, in Solo's mind, that's about as precise as you can get in terms of what it is, what sustainability is. There's one other point that he does mention. He talks about the fact that preserving particular resources, like a particular species or a particular natural area, is fine. It's a perfectly rational and economically justifiable thing to do. Solo's argument is that it's separate from sustainability. If you want to preserve a particular species or maintain a particular natural resource, you can do that for its own sake, and that doesn't necessarily fall underneath the criteria of sustainability. That's kind of it can be fine. It can be very, very rational and justifiable to want to preserve a particular resource. It's just that's not exactly the same thing as sustainability. That's maybe a separate issue, which you can talk about and have a debate about that separately from sustainability, which he thinks more of as being just an obligation to give the future as many opportunities as you have today. That's the kind of the third point that I took away. And then just the last one, which we already discussed, is this paradox of sustainability, which is really tricky. The fact that looking out for poor people today is necessarily at odds with this goal of reducing consumption. If people are poor, they need consumption, not investment. So yeah, that's kind of what my takeaways were, and these overlap substantially with what we just discussed a little bit. What this Solo article sort of puts forward is, I think, this economist perspective of sustainability, where the mandate, the moral obligation is to leave the future at least as well off as you are in the present. Whereas the ecological economics perspective is a lot more inclined to see natural capital, the natural resources, as actually being fundamental and critical, and not substitutable for other man-made capital. And so there ought to be limits on the kinds of takings from the environment that go on in the economy, because of the lack of substitutability between natural capital and man-made capital. And instead, preserving the function and the status of these ecological systems is like the critical thing that's important in the idea of sustainability for an ecological economist, or just an ecological scientist. So we've talked about the fact that we've talked about a little bit of the thorny issues, the thorny ethical issues, the fact that there's a little bit of a paradox, and it's not obvious exactly what should be sustained, whether it's particular resources or whether it's a general capacity to make ourselves better off in the future. This other Tolman article that I had assigned, the Tolman article, it makes this point that it's important to identify what the salient elements of this sustainability concept are. That was one of the phrases from his introductory paragraph. And so I'm going to take each of those one by one and just go through those. And those are the issues of intergenerational fairness. That kind of gets to the ethical imperative or the moral imperative that Solo was referring to. So intergenerational fairness is a key element of this sustainability issue. The object of the sustainability is the other salient element. What is it specifically that ought to be sustained? Is it particular things, or is it a general capacity to produce and to consume in the future? And then the third salient element is the scale of human activity relative to the Earth's capacity to support life. So those are the three elements, and I'll just take those one by one. So the first one, this issue of intergenerational fairness, the standard economics approach to making decisions over time is you assign benefits and costs to any particular action, and those come from like the preferences of individuals in the economy, and so you sort of attribute some kind of average preference that you expect to be true for some future people. They're going to have some valuation for this or that, and we can assign a benefit to them or a cost to them. And then you discount you discount those values back to the present according to some discount rate. So you could say maybe like if your discount rate was 3% per year, you'd say whatever the benefits and costs are next year, we're going to divide them by 1.03. So if our benefit is equal to B, then after 1 year has gone by, and if our discount rate is 3%, then the benefits after 1 year are going to be that value B divided by 1.03. So it kind of scales it down each year, and then the following year it's going to scale it down again, and the following year after that it's going to scale it down again by 3%, and you sort of apply those discount rates to those future costs and benefits, and then you sort of come up with a total amount after you add up those costs and benefits up over time. We'll talk a little bit more about discounting. It's a tricky issue. Again, it's a kind of fuzzy area where it's not scientific. It's kind of subject to ethical preferences. But the main justification and the rationale for discounting has to do with a couple of factors. One is just a pure time preference. As human beings, we have a natural preference to want things now versus in the future. And so part of the rationale for discounting is to take account of that pure time preference. There's another issue having to do with the marginal utility of consumption. I'm not going to talk about that right now. That'll come into play a little bit later in the benefit cost section. So I'll leave that for later. But one of the key issues that I do want to bring up is this capital growth issue. So the one important justification you might have for discounting is that whatever resources you set aside today, they can grow. You can take those resources and use them in production and expand them in the future. That's kind of the idea of invest. You invest money in a company, you buy stock, and over time, that company produces goods and services. They make profits, and you get sort of a growing stream of income in the future. And so there's some preference then for if you have those resources today. If those resources are available to you today, you can invest them and make them grow to a larger amount in the future. And in that case, it's better to have something today rather than in the future, because if you have to wait, you can't put those resources to work and make them grow. Whereas if you have them today, you can do that, and you can actually expand your possibilities in the future. So that's this capital growth argument is one reason why having something today is better. Like if you have $100 today, you can put it in the bank and earn interest on it. And 10 years from now, you'll have, a lot more than $100. Whereas if you have to wait 10 years from now to get the $100, it's not worth the same amount to you because you can't invest it right now. That's another kind of subtle rationale for bringing discounting into the picture. The tricky issue comes in when you have future generations that aren't able to express their preferences yet, and so really it's almost like an equity and distribution argument as to why we discount. It's like whenever you discount, you're implicitly putting less weight on the welfare of future people. And how much do you do that, or should you do that, is a very tricky question. There's actually an economist, Tyler Cowen, who teamed up with a philosopher, Derek Parfit, and they wrote an article arguing for having zero intergenerational discount rate, not having any kind of preference for the present versus the future in terms of generations. So there's arguments for both from ecologists as well as economists for not having any kind of discount rate for the future. And then the final point here, the last point, is that this capital growth argument, the fact that if you have $1 today, you can invest it and make it grow, that could be true as long as there's life support systems to allow that to happen. As long as the natural capital is intact enough where the economy can still produce and you can undertake the normal functions of the economy, then you can grow that money into something bigger in the future. But if you're hindering the capacity of the biosphere to sustain life, that's going to put a obstacle in front of economic growth, and so that capital growth argument might not be valid if in the process of that production you're diminishing the Earth's capacity to sustain life and to sustain the economy. So that's kind of the ecologists' critique of this capital growth rationale for discounting. But it's a tricky issue, and there's not a clear scientific answer to this. It's going to be necessarily value laden. It's going to require making some kind of value judgment about what you think is right and wrong. Okay, and then the second issue that Thoman brings up is this question of what should be sustained. And we got a little bit of this in the solo article that we just discussed, but the economist perspective on this is that it's not any particular thing that ought to be sustained. Maybe some particular things should be, but not under the guise of sustainability. But in terms of purely for sustainability purposes, it's not required that you have any particular thing be sustained, but rather you'd want to have just a increased capacity to produce and consume in the future, which could come from natural capital or it could come from human-made capital. And the economist is a little bit indifferent about which of those sources it comes from. Whereas the ecological economist and ecological economics view is that those capacities to substitute human-made capital for natural capital aren't unlimited. There's probably a limitation on how much you can substitute, and maybe it might not be any degree of substitution. And so what ought to be sustained is the natural capital. Those biological life support systems must be intact in order for humans to be able to survive and to thrive. And so it's critical to specifically preserve those natural resources, those biological support systems, because those may not have any substitute that you can just build with machines or knowledge. So that's the second sort of key element of sustainability, and the two perspectives on that as it relates to ecological economics and standard economics. And then the final issue is it's whether or not there is a carrying capacity on the earth for human beings. So economists tend to think that there's a lot of capacity for human beings to adapt and to solve problems and come up with solutions to things that we used to think were insolvable, and to innovate and to apply new techniques and adjust and move to different locations. So economists tend to think that the scale of human impact is not as much of a limiting factor, because there's all kinds of different ways that we can adjust to whatever constraints we have. If we bump up against a constraint, we can shift around a little bit and expand a little bit in a different direction, whether that's spatially or with a different kind of technology, or using different materials, using electronic file records instead of paper. There's all kinds of different ways that we can substitute physical resources for intangible resources to get the same things that we want. And so the economist perspective tends not to be too concerned about this scale issue, whereas ecologists are sort of trained to think about populations of wildlife and the way that they tend to grow. And then as they get more populous, they bump up into food limitations, and so then their growth rate sort of levels off and eventually reaches like a steady state and is sort of capped at a certain level based on the available food. And so ecologists are much more likely to see the earth as having fixed limits. And even if we get clever and innovative, we can't escape the biological limits of the planet. And so there's kind of a way that we can sort of relate this back to the circular flow model that we had talked about last class. So I actually introduced this a little bit last time. There's this idea of a cowboy economy and a spaceship economy. I think I mentioned the kind of the idea of a spaceship, where inside of a spaceship you're very concerned about all your materials, the flows of materials that you're consuming, and the waste products you're giving off are all staying contained inside that spaceship, and you have to be very careful about what you're doing. The cowboy economy is kind of, you can think about that as like, Americans on the Western frontier 150 years ago that were just moving out west, and they would, withdraw materials from the environment. And if they got too crowded, they could always move further west, and there was always more land and more resources to take from. And so that cowboy economy, maybe that describes humanity, in the pre-modern era, where those resource limitations were not a huge constraint on economic growth and population. But as the scale of that activity grows, we start to become a little bit more like a spaceship, and we start to bump up against the limitations of the Earth's biological capacity to support life, and there might be actually physical limits to how much we can grow in the future. And this is the idea. I had sort of introduced the idea of an open system and a closed system last time. So this cowboy economy is sort of more like an open system, and then this spaceship economy, which we are potentially worried about growing into eventually. That spaceship economy is much more of a closed system, where everything that we all the waste products that we give off into the environment eventually are going to come back to us, because we are populating the entire planet and there's really nowhere else to put the garbage anymore. And so we have to deal with it in the way that we would on a spaceship if we were just contained inside a small little capsule. out in space. So that's the issue of scale, and I have a other terms that we can attribute to this. The chapter 9 in the textbook kind of talks about this cowboy economy idea as being empty world economics, and then the spaceship economy idea. The book talks about that in terms of full world economics. Those are essentially the same things. Those are synonyms for the cowboy and spaceship ideas. But that's the terminology that the textbook uses to describe this problem of the scale of activity relative to the natural environment. These are a couple pictures that kind of illustrate that idea of the size of the economic system relative to the biosphere. So this is the small version, and then the bigger version just has a larger economic subsystem inside the sort of the planetary boundary, and so it expands, and then eventually you expect it to maybe hit a limit in terms of how much it can expand. And then technically, this is called a closed system here, but technically it's open, but the only thing that's coming in and out is solar energy coming in and waste heat going out. So technically closed systems have no transfer of materials inside or outside of the system. And so technically the Earth isn't a closed system because solar energy is coming in, waste heat's going out. But most everything else is going to have to be contained inside the Earth system. Okay, so what do we do about this? Now that we know a little bit about these different perspectives on sustainability, what does this actually mean for the way that we implement policy? So one sort of compromise, or one way that we want to maybe resolve this conflict between strong sustainability and weak sustainability, one potential way to do that is through this idea of a safe minimum standard. So it doesn't give direct advice on any particular thing, but it does kind of give you sort of a decision framework, kind of a way to frame the decisions you make. And it involves kind of this moral imperative to keep ecological damage below a certain threshold. And in fact, as I was looking at your some of your responses to the question of optimal pollution, when I had sent that out the first day of class, a lot of you were hinting at this kind of thing. There was a lot of responses about the optimal pollution is sort of keeping global temperature below a certain threshold, or keeping populations of species above a certain threshold, or avoiding certain catastrophic outcomes. What you guys were actually expressing was some variation of this safe minimum standard idea in those responses. So what this idea does is, if I have a just a little diagram that was in the Toman article here, and if we can characterize our impact on the planet in terms of two different factors. One is the severity of the impact, and the other is the irreversibility of the impact. So some things are extremely severe and severely irreversible. Some things are not that severe and irreversible, and then some things are somewhere in the middle. The idea of a safe minimum standard says that we ought to sort of draw a line somewhere in this problem, and we should say that impacts that we have on the planet that have a certain combination of irreversibility and severity, those should be off limits. We should preclude ourselves from making any of those choices and just leave ourselves constrained and not able to do those activities. We have a moral imperative to avoid those activities. That's the upper left-hand corner of this rectangle. And then we sort of have part of those activities in the domain of morality and moral imperative, And then things that are less severe and more reversible, those are things that we can, where we can start to make trade-offs. So certain activities are completely off limits, and then others, you can think of that as being some kinds of natural capital ought to be preserved at all costs. And then maybe other kinds of natural capital are able to be substituted for man-made capital. And in that case, we should not restrict substitutions or trade-offs. We should allow substitutions and trade-offs to be made between natural capital and human-made capital for those kinds of activities which are below a certain severity threshold and within a certain threshold of reversibility. So we want to do that for things which are mostly reversible and not that severe. But as the severity increases and as the irreversibility increases, then we start to get into a situation where we might want to consider just having those things be off limits completely and having a moral imperative to avoid that stuff. That's kind of the balance between strong and weak sustainability that this safe minimum standard recommends. So that's kind of the theoretical framework of the safe minimum standard. There's different ways we can think about implementing this. So I have a list here of some candidates, some things that could function as safe minimum standards. So you might think about a minimum viable population of a certain species would be one candidate for a safe minimum standard. Having a minimum amount of water per second flow through a river would be another minimum standard, where you just decide you don't want that river flow to drop below a certain threshold, and so you voluntarily stop withdrawing after a certain point from the river in order to maintain that flow. You might have an index of biological diversity, maybe you don't necessarily want any particular species preserved, but having some variety of species preserved could be your threshold or your safe minimum standard criteria. Or you could also have greenhouse gas concentrations. You could say we don't want to see what's going to happen if we get CO2 concentration above a certain threshold. So that's going to be where we want to draw the line in terms of what we allow economic activity to produce. So the Endangered Species Act is one example of this. So under the Endangered Species Act, when ecologists will kind of take surveys of populations, of wildlife populations, and find types of species that are threatened or endangered, that are at risk of becoming extinct, and then sort of in the spirit of the safe minimum standard, you want to prevent the loss of those species, and so you start to designate critical habitat, and you formulate a recovery plan to ensure that the species has enough food, enough space, enough shelter, enough sites for breeding, in order to make sure that population it stays intact in the future and is prevented from disturbance and potential extinction. One of the key things that's tricky here is it's fine to say that we want to preserve this species and give it some habitat and make sure it has some food and breeding ground sites, but it's fuzzy when you talk about space for populations or food. How much exactly is the minimum that's required for these species? Is there no scenario in which we can take away a little bit of their habitat and have them still be able to survive? Exactly how much is that? That's a difficult question to resolve, a difficult practical question to resolve. And so even in the case where you define a safe minimum standard in this way, you're still kind of left with how much habitat, how much food, how much breeding ground sites is necessary to maintain that species. And so it kind of helps to resolve that tension between kind of the strong sustainability and the weak sustainability. But at the end of the day, you're kind of still left with this need to make choices and potentially make trade-offs between one use of land for habitat versus maybe using it for something else. So it's, at the end of the day, it's still a very tricky thing to resolve. Okay, so this will kind of wrap up. This will wrap up our discussion of kind of the themes in environmental economics and questions of scale and questions of sustainability. Those kinds of things are going to come back up throughout the rest of the semester, but we're going to move on from here to talking about some microeconomic concepts that are going to be critical for upcoming sections of the class and critical for your homework 1 and homework 2. So that's what we'll be covering next class. If there are no questions, have a good rest of your day, and I'll see you on Friday.